saying that a pair of the conjugate of a complex number, conjugate of a complex number Z is the complex number obtained by changing the sign of imaginary part. Very easy, but this is important. Imaginary part of Z. It is denoted by Z bar. Denoted by Z bar. Okay. So Z bar. Let's give one example, then it will be much more clear. Suppose one complex number is given. Suppose Z equal to given 5 plus 6i. Okay. So what will be Z bar? Z bar will be 5 minus 6i. Okay, what definition is saying again? Let's see. The conjugate of a complex number Z is the complex number obtained by changing the sign of imaginary number. So what was the imaginary number? 6i. Sign was plus. Okay, so we change the sign. So it is denoted by Z dash. And another, we'll discuss some properties also. So, but still, I'm saying that when the complex number and the conjugate of the complex number will add, look, the imaginary part will cancel, right? Because it is plus 6i and Z dash is minus 6i. So only real part will be there. So conjugate meaning of the conjugate is also same. The pair of if a pair of a complex number, if we add the complex number, if it is equal to a real number, then this pair of the number is called conjugate. Okay, that is also a what do you call? That is also not definition, but just a meaning of a conjugate. So now conjugate we learn. Now we have to learn the what is modulus. Modulus means the real value. That means so modulus you have to write like this. the modulus of modulus, or it is known as absolute value also, but we use the modulus of a complex number z equal to a plus ib is defined as the non-negative real number square root of plus b square. Okay, it is denoted by mod z. Okay, it denoted by mod z. So that is mod z equal to this. Okay, they basically, what is this? The modulus is the value, the non-negative real value of the number. So suppose the complex number is z equal to a plus ib, so the real part squared plus the imaginary part squared, that will give you the modulus. Okay, they are sum of the square and plus and then square root. Okay, and it is denoted by mod z, mod sign, modulus sign, so this is the two part. Now let's give one example. Let's take this example. If you take this example, what will be the mod z? Mod z will be equal to square root of 5 square plus 6 square. Okay, 5 square and 6 square. So that is the thing. Now for some properties in your book given, okay, not all the properties, in if you are doing in JEE, then okay, suppose after that now you have to find the value. So this value will be square root 5 square is 25, 6 square 31, 25 plus 31 is something 56. This is the value. Okay, so this kind of question will be there. Some properties is given here for any two for any two complex number for any two complex numbers and Z2. There are few properties. First is modulus of Z1 Z2. Modulus of Z1 Z2 is equal to modulus of Z1 into modulus of Z2. Okay. This is number 1. Number 2, is, first I'm writing all this one, then I'll explain. Then modulus of 2 is equal to modulus of this Z1 divided by modulus of Z2. Okay, here one information you have to write, where mod Z2 greater than 0 or not equal to 0, not equal to 0. Number 3, let me write the properties, then I'll explain. Then it is Z1 Z2 equal to Z1 then plus minus 2, which is equal to Z1 plus. Then the last one equal to okay. So all these are the 5 properties given. Basically, complex number have a lot more properties actually. Okay, but here we have only this much, so we'll only discuss this much. So what is saying here? These properties we may use later. Okay, few properties that modulus of Z1 Z2 is equal to Z1 and Z2. You can prove all these one by taking any two complex number. Okay, I'm giving you one proof only. Okay, for number 1, I'm giving you one proof. For here I'm giving one example. Suppose Z1 z1 equal to 2 plus 3i and z2 equal to z2 equal to 3 plus 5i. Okay, so what is the given? Z1 into z2 modular. So first find out z1 z2, z1 here and z2. First find z1 z2. If you find z1 z2, it will be 2 plus 3i in bracket 3 plus 5i. If you simplify this one, I'll do a little bit faster. 3 into 2 is 6. Okay, then 2 into 5 is 10i. 3 into 3 is 9i. You can do by yourself also. Plus 15i, sorry, 15i square. So after simplification, it will be 6 minus 15, so minus 9 plus 19i. Okay, simplification you can do by yourself. So z1 into z2 we got minus 9 plus 9i, right? Modulus means we have to find the absolute value. Okay, so modulus of, write down left hand side, modulus of this one is equal to square root minus 9 whole square plus 19 whole square. Okay, if you simplify this one, it will be square root of minus 9 is 81, 81 and 361, it will be like 2, 8 and 6 is 4, 4, 442 I guess, 361 and 81, yeah, 442. Okay, this is the our value of this. Now we have to find out mod z1 and mod z2 separately, then we will find their product. Okay, mod z1 will be equal to, mod z1 will be, look, mod z1 is 2 plus 3i, right? So mod z1 will be square root 2 square plus 3 square. It will be equal to 2 square 4, it will be 30. Okay, then z2 will be 3 plus 5i, right? z2, so it will be 3 square plus 5 square. So it will be 3 square, 9 plus 25. 9 plus 25 is 34. Okay. Now right hand side, this one. Right hand side this one equal to, it will be, look, root over z1, the value is 13. I put a 13, and root over z2, that is 34. If you multiply this thing, I think we will get the value 34 and 13 into 34. Yeah, we will get the same value we got previous, 442. Okay, so this is the example. So you can prove all these properties by using this formula. Okay, properties. So you in your syllabus the proof is not there, so I'm not wasting the time for doing this. If you want to do, you can do. Okay, let's move on to the last part of the exercise. Move on to the last part of the exercise, that is 11, 12, 13, 14. Okay, 11, 12, one question I will do, and the rest of the problem you have to do by yourself. So what the question is, I hope if any doubt regarding of this, up to this, any doubt, please let me know. If anyone have any doubt regarding this, because the question will be regarding so many questions that I did not understand. Can you explain the please the example again? Said is not it root 61? Okay, I have to check again. Root 61. Okay. Um, well, this is the given. This is I gave this one for exam for number one. Number one is saying modulus of z1 z2 equal to z modulus of z1 into modulus of z2. Okay, that what we are going to prove. So I am taking z1 equal to 2 plus 3i and z2 equal to 3 plus 5i. Okay, modulus means I hope this part clear. Conjugate means we have to change the sign of the imaginary part. Okay, and modulus means whatever the number, suppose the number is a plus ib, modulus of z is root over a square plus b square. That is the modulus, the absolute value. Understood? Then, so first here we have to prove this one. I told there is 5 proof is there, right? So you can other one you can do by yourself, and this one only number one I'm proving only number one. Okay, so what I'm saying, I'm taking one example, z1 equal to 2 plus 3i and z2 equal to 3 plus 5i. Then z1 plus z1 into z2, multiplication of complex number. So this to multiply, 2 into 3 is 6, 2 into 5 10 I, 3 into 3 9 I, 2 into 3 into 5 15 I. So 6 minus 9 5 15 is minus 9. Okay, so like this. Okay, so next is modulus of z1 z2. Z1 z2 we got one complex number, that is minus 9 plus 99, right? Look here, 15 I square means minus 1, so 6 minus 15 is minus 9. Okay, and 10i plus 9i is 99. So modulus of z1 z2 will be minus 9 square plus 19 square. If you simplify this one, you will get this. Understood? Number one. Then right side is what? Right side is that modulus of z1 into modulus of z2. So we have to find modulus of z1. Modulus z1 is what? 2 plus 3i. So modulus of z1 will be square root of 2 square plus 3 square, that is equal to 2 square is 4, 4 plus 9 is 30. Similarly 3 plus 5i, so z2 will be 3 square plus 5 square. So 3 square 9, 5 square is 25 to 34. So modulus of z1 into modulus of z2. It will multiply right hand side. If you multiply, we are getting right hand side 442 root over. So look, left hand side and right hand side equal. That's what our proof is. Therefore, LHS equal to RH. Is it clear now? Now the explanation is clear. Look, the this proof, all the proof, all the other proof you can do by yourself. Okay, because I'm saying this is not in your I mean like proof is not there in your syllabus, So I'm not giving much time to prove the other thing or giving homework also. The 2 3 4 5 you can do by yourself and you can check again. Now I'll move towards the problems given in your book, though very less problem given in your book. From 11 12 13 I'll do one problem. I'll do question number 13, exercise 5.1. Exercise 5.1, page number 110. If you have the book, please open the book. Okay, this question saying find multiplicative inverse of each complex number in the given 11 to 13. Multiplicative inverse means we have to find the conjugate and the modulus. Okay, we have to need to find the complex number, this one. How to find? Let me show. Multiplicative inverse means, oh, one thing, let me show you one thing. Here I must forget one thing, that is multiplicative inverse. Let me say you what is multiplicative inverse, then I will explain. Multiplicative inverse of a non-zero complex number Z is given by okay, multiplicative inverse is given by Z to the power minus 1, Z inverse, okay, and it is given by Z bar divided by mod Z square. Okay, this is the multiplicative inverse formula. Understood? So we learn these two formula, not formula, I mean the way how to find the Z bar and mod of Z. So we have to find the Z bar and mod of Z, then the Z square to find the multiplicative inverse. Okay, okay. And one more thing, from here we can draw one thing, that from here we can write one form, or I'm writing as a or Z into Z bar is equal to mod of Z square is equal to mod of Z square. Okay, from here we can draw this extension also. This part is not that important. Okay, we have to follow this rule, Z inverse equal to Z bar divided by mod Z square. So now come to the question. I'm doing one problem, other two you have to do by yourself. Okay, question number 12 I'm doing. Question number 12 is saying square root of 5 plus 3i. Okay, so 11 and 13 will be the homework. Let's do. So z given, let's write, or you can here write down z equal to this. Whenever whatever the complex number given, right, give this one z. Okay, therefore z bar will be, we know that conjugate means just we have to change the sign of the imaginary part. So module z bar will be root over 5 minus 3i. Z bar means conjugate of the complex number. Next, what will be the z bar? Z bar will be, sorry, z bar will be square root of 5 square plus 3 square. Okay, or you can write like z bar square. You can directly write z bar square. So you can put here bracket and outside also bracket square. So one thing we can see from outside square and this square root, it will cancel. So inside will be 5 square plus 3 square. 5 square is how much? 25 plus 9, which is 34. So therefore z inverse will be, or multiplicative inverse of the complex number will be, write down this, is equal to z bar we got this root over 5 minus 3i, and z bar square we got 34. Okay, so now you can split the number like this, denominator 34, numerator square root of 5 minus I into numerator, it will be 3 divided by 34, or you can write like this 3i, any number. Okay, is it clear? Very easy. To be honest, this is very easy part. Okay, now we'll do any doubt regarding this. If you can represent, better to represent like this. Okay, better to represent like this. You can end the question here, but better to represent like this. I'll do another one problem, that is question number 14. 11 and 13 will be the homework. Question number 14 is saying one expression is given. We have to convert this one in a plus ib form. Okay, so let's write down the expression in bracket 3 plus, if anyone have doubt, please write down now, square root of 5 3 minus root of 5 divided by square root of 3 plus square root of 2 I, sorry, minus Let's see any doubt on. Sir, the position of I, yeah, position of can be in front of the I can be first also, I can be here also, no problem. Okay, or you can write even sometimes we used to write like this also, 3i divided by 34, no problem. But better to split like this, okay, so that sometimes it used to ask that write down in a plus ib form, okay, and what is a and b. So you can easily say this is a and this 3 by 34 is b, okay. So here in the next question you can see we having some complex expression. We have to convert this one in a plus ib form. So we have to just multiplication in the numerator and denominator, we have to do the subtraction. So numerator it will be 3 into 3 9, okay, then minus I 3 root 5. Okay, look, 3 and minus root I5 multiply, so I 3 root 5, then plus I 3 square root of 5, then minus I square 5. Root 5 into root 5 is 5. So denominator it will be, you open the bracket, if you open the bracket, it will be minus, here also minus sign, okay. This if you open the bracket minus root 3 minus it will be plus. So you can see something is something can be cancelled, this part is cancelled, okay, minus I root 3 5 and my plus root I 3 5, and denominator minus root 3 and plus root 3, this part cancel, then equal to numerator will be 9 minus I square also I square also 1 minus 1, so I square 5 will be minus 5, okay. Denominator will be root 3i plus root 3i, it will be 2 root 3i, okay. Then it will be you just simplify. Before simplification na, try to do one thing. Okay, first simplify, then I'll tell. Denominator so it will be same, numerator will be 9 plus 5, 9 plus 5 is 14, okay. So from numerator denominator 2 to cancel, it will be 7 divided by root 2 into I, 7 divided by root 2 into I. So next we have to do one thing, we have to what it called this rationalize, have to rationalize the denominator, okay. So we will remove the I and root 2 from denominator, so it will be denominator sorry numerator it will be 7 root 2i, numerator it will be 2i square, which is denominator will give you minus 2, numerator will give you 7, this one, okay. So ultimately this will be a minus 7 by 2 root 2 I, root 2 and I like this, okay. After that you can write, after that you can write here, this just additional, a equal to 0 and b equal to minus 7 by 2. Okay, because we asked to write in a plus ib form, right? So a plus ib form where a is 0 and b is minus 7 root 2 by 2. Okay, don't write I here because b value is this, I already multiplied. Understood? So this is the fact. This is the last question. After that now I will give you few questions. Last topic I will discuss next day because one topic left. If I start now, it will not be finished. So last topic we'll discuss the topic next class, and let's discuss few other problems also. Few questions from the. I'll try to give this one this consider. Okay, one question is given. Extra problems. Suppose one question is given. Find mod of 1 plus I, then 3 plus I, 3 plus I, numerator denominator 2 plus I. Then okay, we have to find this value, that 1 plus I, then this value. So in this question, actually here the question asks to find the modulus of this one. Okay, so we have to take z, let z equal to this, let z equal to this. Okay, so after this one we can simplify. Numerator will be 1 plus I and 2 plus I, denominator will be 3 plus I. If you simplify numerator, you will get 2 plus I plus 2I plus I square divided by 3 plus I. Okay, divided by 3 plus I. So here, if you simplify the numerator, you will give 2 minus 1, so it will be 1 plus 3I. So look, I am doing little bit shortcut also, like here 2 plus I square means minus 1, so I'm directly writing 1. Okay, 2 minus 1, and I plus 3I is obviously, you know, 3I. So this is the value of Z. This is the value of Z. Now we have to find the modulus of Z. To find the modulus of Z. Okay, how to find? So mod Z equal to mod this. Okay, this one is equal to one. If you remember one property, the property number, which was this property. Look, modulus of z1 by z2 is equal to modulus of z1 divided by modulus of z2. Okay, we will use this property. Property number 2. We can copy from here. We'll use this property. This one. Inside the bracket, we will write like this. you know this. Okay, so it will be modulus of 1 plus 3i divided by modulus of 3 plus I, which is equal to square root of 1 square 1 square plus 3 square divided by square root 3 square plus 1 square. So you can see we can from here 1 square plus 3 square you will get root over 10 and denominator also root over 10. Okay, so if you cancel this one, the answer will be 2. So I'm not doing. So this is the answer. Okay, another problem is this problem. I'm giving you homework. One problem I'm giving this one homework. If z1 is equal to 2 minus I, comma z2 equal to 1 plus I. z1 is 2 minus I, z2 is 1 plus I. Then find z1 plus z2 then plus 1 divided by z1 minus z2 plus 1. Okay, this question is homework. Marking this question as homework. Okay, this question is homework. Okay, then any other? Just give one examples from this. Okay, it's okay. Today's class we took this much. Okay, so homework will be this, and from your exercise question number 12 and 13, I guess. Sorry, 11 and 13. 11 and 13. All these I will you just make sure this one. Okay, so these two will be homework. All this homework I will make a port for this week. Okay, and you have to upload there. And some of your I want to see say some of your homework is not submitted. I think you have to submit the homework. Okay, like I'm giving you the names. Wait.